All right, yeah, we're going to start by listening to or watching a real quick video to introduce the next topic. So I'll just go ahead and get going here.
Joy Milne first noted something odd about her husband's scent when he was 45. Shortly afterwards, he was diagnosed with Parkinson's. Now universities are testing if it's a coincidence or a newfound precaution. Here's Mike McCarthy from our British partner, Sky News.
When she was a teenager, Joy Milne started to realise that she had an acute sense of smell. But it was only when she noticed a change in her husband Les's odour that the incredible potential of her super sense became clear.
He was anaesthetist, he was in a close situation in theatres and he was working long hours, and I presume the Parkinson's tiredness had kicked in then, but we didn't know that. And because he was so tired, I just thought, well, you're not showering enough, and I said to him.
At first, Joy didn't know what the smell was until she recognised it in other people and said so at a meeting to discuss Parkinson's.
And I thought, this is it, this is the right moment. And I stood up and said, why are we not using the smell of Parkinson's? I can smell it in this room all around me.
Now at Manchester University, researchers supported by the charity Parkinsons UK are harnessing Joy's special skill.
Once Joy's incredible ability had been recognised, she was given by the university a number of t-shirts. Now, half of them had been worn by Parkinson's sufferers, the other half by a control group. She got them all right, apart from one.
No, stop listening.
Scientists believe that Parkinson's may cause
All right. I'm not sure if you guys heard that last part, but whatever. It's fine. All right. So, overall, the general vibe of this is that this woman, her husband got Parkinson's disease, and she was like, oh, he smells, right? He's starting to smell different, he's not showering enough. And then she went into a room that was like a support group for people with Parkinson's disease to learn more about Parkinson's disease. And she said everybody in this room has this smell. So this woman says she can smell Parkinson's disease, like whether or not a person has Parkinson's disease. What do you guys think so far? Does that feel like a realistic thing? Holland Chicken said no. Jackson's saying no. What do you think? No? Huh. So, let's start with, why do you think it would be important to know whether or not we could smell Parkinson's disease? Yeah.
You can catch it early, so it doesn't get super household.
Earlier detection, for sure. With that earlier detection would come earlier treatment. What else? What would make somebody start to smell funny? Like it'd be like a chemical change in their body, right? And so maybe if they can treat with that change in chemical, like it also could influence new treatments, right? You guys with me? Because that could give an idea of like the underlying cause. So it could possibly influence the new treatments based on what they find, okay? All right. So Joy got them all the t-shirts right with the exception of one. Okay, we'll worry about that last line that I was supposed to pause it before you saw it anyway. Okay. All the t-shirts except for one. So, but they didn't really tell us how many she had. So, my first question is, would you be convinced if she got 2 out of 3 t-shirts correct? Would that convince you? What about 4 out of 5? What about 9 out of 10? We're starting to feel a little bit better. What about 11 out of 12? A little bit better? Maybe? Is anybody not convinced at 11 out of 12? It would be shocking if if all of you were convinced that if she got 11 out of 12 right. That would shock me.
I mean, I don't know why they only did 12. I mean, they could really easily do a larger test.
Sure. What about 15 out of 16? Would that convince you?
Sure.
99 out of 100?
Yes.
That would definitely convince you? Okay, so I want to talk through this whole idea of what it takes to convince us. Okay? So we're going to operate on the 11 out of 12. Okay? So she correctly identified 11 out of 12 shirts. If she was just guessing and she can't actually smell Parkinson's, how many shirts would you guys expect her to get correct? 6. Half of them, right? Because she's choosing between two options, right? So that's what we would expect to happen. And then 11 out of 12 is better than expected, yes? All right, well, essentially, there's 2 ways we can explain why she got 11 out of 12 right, which is better than expected, yes? What's one explanation of it? Guesswork? In other words, she's lucky? And if that's the case, if she is still guessing and she just got lucky, what's the true proportion of correctness for her? If I asked you what percent of the time, if she's just guessing, what's P? 0.5. What's the other explanation? She can smell Parkinson's. Now, are you guys with me that the she can smell Parkinson's means she's doing better than just guessing? Okay? So her true proportion of success is maybe higher than 0.5. That P still being a true proportion, blah, 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 of... Everybody good? All right, so we're about to embark on doing tests of significance, sometimes called hypothesis tests. And so we always start with 2 kind of competing hypotheses. We have the boring one. The boring one is the one that, like, nothing is actually going on here. We call this one the null hypothesis. She can't smell Parkinson's. She's just lucky. No conclusions. Null. Nothing. Okay? And we notate the null hypothesis with an H with a subscript of 0. All right? We call this other one the alternative hypothesis. And we notate that with an H with a subscript of A. Okay, so we have HO and HA is kind of how we talk about those. All right. So, could she have gotten 11 out of 12 right by chance?
Yes.
Absolutely. It's always the answer to, is it possible that this weird sample happened by chance? The answer to is it's possible is always yes. It's always possible. Okay? That we have some huge anomaly of a sample. Okay? Is it probable? How probable is it? To figure that out, we're going to go through a little activity. It's going to go like this. I'm going to put you guys in pairs somehow. Like, I'm going to have you guys pair up. Each pair is going to get a set of cards. There are 12 cards here. 12 cards representing 12 t-shirts, yeah? And when Joy did this, they were half Parkinson's, half worn by people with Parkinson's and half not, right? Half of these cards say Parkinson's on them. The other half says not Parkinson's on them, okay? I'm going to point out that I'm shuffling this so that the cards are given to you in a random order. Now, you guys, were these note cards worn by somebody with Parkinson's? No. That doesn't even make sense, right? Okay, so and what we're going to do is you're going to go through and you're going to, just guess for Parkinson's versus not Parkinson's. You guys with me here? Which of my two hypotheses does this model? The lucky. The null hypothesis, right? Because what's your proportion of success on any given card here? 50-50. So for you guys, as we do this, we get 50-50. Everybody good? And so it's basically going to go like this. Matt, do you mind helping me out here? You sit right there. You're fine. All right. All I need you to do is very discreetly count how many I get correct. What worked well yesterday is kids counting on their fingers underneath their table. Everybody good? And just for good measure, I'm going to close my eyes. Parkinson's. Parkinson's. Not Parkinson's. Not Parkinson's. Not Parkinson's. Parkinson's. Not Parkinson's. 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 Not Parkinson's. How did I do?
Got
3? Perfect. That's it. You guys, I'm not very good at this. All right. So then what I'm going to do is everybody gets one sticker, right? You're going to put your sticker on this dot plot. Everybody good? All right. So, and then at the end, we're going to do a comparison to how many times, by guessing alone, people got 11 out of 12, right? And say, hey, what's the likelihood that happens? Everybody good? All right, so let me pass the card. You two can go together. You two. You're just guessing. I get that it feels. You are just guessing.
Yeah, because that's exciting.
Okay. Yes.
Parkinson's.
Parkinson's.
Not Parkinson's.
No, you're not supposed to work out of it.
Not Parkinson's.
Yeah.
Not
The
Parkinson's.
way she did it was she like.
Does it matter which way
not
you guess?
Parkinson's.
What do you mean?
Parkinson's.
Yeah.
Not
Does it matter?
Not Parkinson's.
No.
Can I look at it and make those
Yeah.
guesses right now?
No.
If it's not
Yeah, I feel like that's fine.
Not Parkinson's.
You're shuffling.
As long as he doesn't know if he got it right or wrong. Like, so whatever it is, it has to be very discreet.
Yes. Yes. No. Yes. No. No.
I hear.
Yes.
Okay.
Yes.
Parkinson's.
No. No.
4.
I'll take it.
Parkinson's.
They were literally right under the bar chart.
Yeah, 44.
Yeah.
Yeah, 7.
Oh, nice.
Yeah, 8. What? Actually, genius, man.
All right. You guys. As of right now, is anybody convinced? Or does anybody still question whether or not she can smell Parkinson's if she got 11 out of 12 right?